Okay, I hope I'm audible to all students who are attending this lecture of Intermediate Microeconomics Part 2. In this particular lecture, I intend to discuss my assignment on monopoly and imperfect competition. Okay, so let's start with the practice problems on monopoly from my assignment. Okay, so the first part is basically the Snyder and Nicholson back questions of monopoly. And if all students can recall that we have done good practice of the back problems of Snyder and Nicholson for the monopoly chapter. Okay, this is chapter 14 of Snyder Nicholson, and we have solved almost all these questions we have solved in our lectures on worked out problems for Snyder and Nicholson. Okay, now in this lecture, we start with our discussion of question B. Okay, so let's read question B. Given the demand function for the number of rides x, which is equal to 50 minus 5p, where x denotes the number of rides and p denotes the price per ride, and we are also given that the marginal cost per ride is equal to 0. The question is asking us, what is the profit maximizing price and quantity produced by the monopolist? Okay, so let's quickly come to the whiteboard and let's solve this question. Okay, so we are starting with the discussion of assignment 1. This is assignment 1 for monopoly and imperfect competition. Assignment 1 for monopoly and imperfect competition. And in this particular lecture, we are looking at questions on monopoly. From assignment 1, we are looking at questions on monopoly, and we are looking at question B. Okay, so let's quickly write what's given to us. So we are given that the demand function for rides is as follows. The demand function for rides is as follows. X is equal to 50 minus 5p, where p is the price per ride. P is the price per ride, and we are given that the marginal cost is 0. Okay, so let's look at what part 1 is asking us. We need to find out the profit maximizing price and quantity produced by the monopolist. Okay, so first of all, let's quickly write the expression for profits. Okay, so the profit of the monopolist is nothing but total revenue minus total cost. Okay, let's quickly write the expression for total revenue. So we are given that the demand function is x is equal to 50 minus 5p. So I can write this in terms of x now. So I can write, therefore 5p is equal to 50 minus x, which implies the price is 50 minus x by 5, which is equal to 10 minus x by 5. Okay, so my total revenue will be equal to price into the number of rides. P is nothing but 10 minus x by 5. P is 10 minus x by 5 into x. This is equal to 10x minus x square by 5. This is my total revenue. Okay, and if I look at the total cost is 0. So at the profit maximizing level, what should happen? Marginal revenue of the monopoly should exactly be equal to the marginal cost. So I can quickly calculate the marginal revenue first. So if I differentiate total revenue with respect to the number of rides, what do I get? 10 minus 2x by 5. That is my marginal revenue. My marginal cost is given to us as 0. I can write that at the profit maximizing level, at the profit maximizing level of the monopolist, what should happen? At the profit maximizing level of the monopolist, marginal revenue should be equal to marginal cost. Marginal revenue is 10 minus 2x by 5. Marginal cost is 0. solve this for x. So we get 10 is equal to 2x by 5, which implies my x is 10 into 5 by 2, which is 25. So I can write the answer for the first part. How many rides will the monopolist give? 25. What will be the price charged by the monopolist? Put it in this expression for price. So I can write PM will be equal to 10 minus XM by 5. XM we have already calculated as 25. This is going to be 25 by 5. This is going to be 10 minus 5, which is 5. This will be the price charged by the monopolist. And what will be the profit of the monopolist? Profit is nothing but price into quantity minus total cost is 0, because marginal cost is 0. So I can write my profit of the monopolist is only PM into XM. Because the marginal cost of the monopolist is 0, total cost is also 0. Assuming there are no fixed costs given to us in the question. So the profit of the monopolist is PM into XM. PM is how much? 5. XM is how much? 25. So the profit of the monopolist is 125. So for question B, part 1, the answers are as follows. The monopolist is going to give 25 rides. Okay, the price charged will be ₹5 per ride, and the monopolist is going to make a profit of 125. This is my answer for part 1. Okay, then let's look at part 2. If the monopolist practices price discrimination now, what is going to be the total revenue of the monopolist under OI tariff and under optimal tariff? Now, we have done the concept of OI and optimal tariff in our lectures on monopoly within our topic second degree price discrimination. Okay, so let's quickly solve part B, part 2. Okay, so erasing this off. So I'm going to draw a table now where I'm going to do the analysis for OI tariff on one side and the optimal tariff on the other side. Okay, so erasing this off. Let me draw a table where I do the OI analysis on one side and optimal tariff analysis on the other side. So this is part 2 to the question. Okay, so we are looking at the OI tariff here and we are looking at the optimal tariff here. Okay, so first, if I quickly draw a demand curve. If I plot this demand curve, let's see what do we get. So we have X and we have P here. Okay, and when I plot them, when X is 0, P is 10. When P is 0, X is 50. So it is when X is 0, P is 10, and when X is 50, P is 0. This is my demand curve. Okay, and my marginal cost is 0. So I can say that my x-axis or the horizontal axis is my marginal cost, which is equal to 0. Okay, now what happens under OI tariff? All students can recall from my theoretical lectures on monopoly. Under OI tariff, my P is equal to A plus PQ, where the price charged is equal to the marginal cost, and A is the fixed fee. A is the fixed fee, which is equal to the consumer surplus. Okay, so my price is equal to the marginal cost, which is 0. And what is A? This is A. This whole thing is my consumer surplus, guys. Area below the demand curve and above the price. The price is equal to the marginal cost under OI tariff. So my A will be nothing but the area of the triangle, which is half into base is how much? 50 into height is how much? 10. So my answer is going to be 250. So A is 250, P is 0. So my T will be what? T will be equal to 250 plus P is 0 into Q, which is equal to 250. So clearly under OI tariff, the monopolist is going to charge a price equal to 0 because marginal cost is 0, and will charge a fixed fee, which is exactly going to be the consumer surplus of the buyer. The consumer surplus is nothing but the area below the demand curve and above the price. The price here is equal to the marginal cost, which is 0. So A is nothing but the area of the shaded triangle, which you can see, which is half into base into height, which is 250. Okay. Now let's see what happens under optimal tariff. Now, under optimal tariff, first of all, if you all can recall, we had calculated the expression for marginal revenue. So under optimal tariff, first of all, what was my demand function? Under optimal tariff, it was, so X is equal to 50 minus 5P, which implies 5P is equal to 50 minus X, which implies P is equal to 10 minus X by 5. This was my demand function. Price is a function of quantity. Okay. My total revenue was P into X, which was equal to 10 minus X by 5 into X, which was equal to 10X minus X square by 5. And what was my marginal revenue? If I differentiate total revenue, what do I get? 10 minus 2X by 5. This was my marginal revenue. Now, under optimal tariff, what is going to happen? So if I draw a diagram, so this is X, number of rides, this is P. My demand curve is again passing through 10, 50. This is 50, this is 10, this is my demand curve. If I plot the MR curve, guys, how will I plot it? MR and X. When X is 0, MR is 10. When MR is 0, how much is X? I'm solving it here. 0 is equal to 10 minus 2X by 5, which implies 2X by 5 is equal to 10, which implies X is 10 into 5 by 2. This is 25. So when X is 0, MR is 10, and then it passes through 25. So this is my marginal revenue curve. My marginal cost is how much? Marginal cost is equal to 0 only. So under optimal tariff, what will be my tariff? P will be equal to A plus PQ, where P is the price. P is the price consistent with MR equal to MC, and A is the consumer surplus of the buyer. A will be the consumer surplus of the buyer. I can write it here. So P will be equal to A plus PQ under optimal tariff, where P is the price consistent with MR equal to MC, and A is the consumer surplus of the buyer. So if I equate MR equal to MC, what do I get? So erasing the initial part off, let me erase this part off. So erasing this part as well. So what I'm doing now is I'm equating MR equal to MC. Okay, so let's do that. So I can write MR equal to MC implies MR is how much? How much was our MR? Our MR was 10 minus 2X by 5. MC was 0. So 10 is equal to 2X by 5, which implies my X is 10 into 5 by 2, which is 25. So my X is 25. And corresponding to it, how much price will the monopolist charge? So this will be the quantity of the monopolist in this case. And what will be the price? If I put X equal to 25 in the demand function, so my P was how much? My P was 10 minus half X, which is equal to 10 minus half into X is how much? 10 minus 1/5. Let me correct myself. This is 1 by 5, guys. So 10 minus 1 by 5X, which is equal to 10 minus 1 by 5 into X is 25. So this is 10 minus 5, which is 5. So the price charged by the monopolist is 5. Okay. The quantity produced by the monopolist is given by the condition MR equal to MC. Corresponding to it, if I put X equal to 25 in the demand function, I get price as 5. What will be my consumer surplus now? the consumer surplus will be nothing but the red shaded triangle, which is the area below the demand curve and above the price. Now, what is the price? It's 5. So my consumer surplus will be, my fixed fee will be equal to the consumer surplus, which is the area below the demand and above the price. So I can calculate my A. It's half into base is how much? 25. Into height is how much? 10 minus 5, which is 5. So how much will this come out, guys? 25 into 5 divided by 2 comes out as 62.5. So if I put the value of A and P, what is my T? For optimal tariff, my T is equal to A plus PQ. A is 62.5. P is 5 times Q. How much is Q, by the way? Q is 25. So my revenue under optimal tariff will be 62.5 plus 5 into 25, which is, you can calculate it. This is 187.5. So clearly you can see that under OI tariff, the monopolist is earning a revenue of 250. And under optimal tariff, the monopolist is earning a revenue of 187.5. So hoping all students have understood question B part 2. Okay. So we are done with question B. Let's quickly look at question C, and that is the last question I will be looking at in this particular lecture for discussion. Okay. Suppose a monopolist serves two markets, A and B, selling the same product. Okay. The demand function in market A is QA equal to 100 upon PA square. And the demand function in market B is QB equal to 125 upon PB cube. Both markets A and B have the same marginal cost. In market A, we are given that the monopolist is selling 100 units. So we are given that in market A, the monopolist is selling 100 units. Okay. Part 1 is asking us calculate the price charged by the monopolist in markets A and B. Okay. And part 2 is asking us how much will the monopolist sell in market B. Okay. So let's quickly solve question number C on the whiteboard. So erasing this off, let's look at question number C. So I can divide my entire analysis into two markets, market A and market B. So this is market A, and here we have market B. And what is given to us? We are given that in market A, my demand is QA equal to 100 upon PA square. In market B, we have QB, which is equal to 125 upon PB cube. Okay. And we are also given that in market A, the price is equal to 1. That information is given to us. Okay. In market A, the price is equal to 1. Okay. And what else is given to us? Okay. So we are also given that both markets have the same marginal cost. That is also given to us. And we are also given that the monopolist is selling 100 units. Okay. We were not given PA. Let me correct myself. We were given that in market 1, in market A, the monopolist is selling 100 units. QA is equal to 100. This is given to us. So first of all, we were given the demand functions facing the monopolist in markets A and B. And we were given that in market A, the monopolist is selling 100 units. Now I need to calculate all other variables. I need to calculate what's the price charged in market B. I need to calculate what's the price charged in market B. I also need to calculate how much is sold in market B. Both these things I need to calculate. Okay. So first of all, since we are given QA equal to 100, I can put it here in the demand function. So I can write since the monopolist is selling, since the monopolist is selling 100 units in market A, since the monopolist is selling 100 units in market A, therefore 100 is equal to 100 upon PA square, because I put the value of QA as 100 in this. So what do I get? This is nothing but PA square equal to 100 by 100, which is equal to 1. So my PA is equal to 1. Price charged in market A is equal to 1. Okay, this is given to us. Then if I quickly calculate the marginal revenue in both the markets, now what will that be? So I can write PA square is equal to 100 upon QA. QA is 100 by PA square, so PA square is 100 upon QA. So this implies my PA is how much? 50 upon QA to the power half. Okay. What will my total revenue be? So total revenue in market A is nothing but price in market A into quantity in market A. PA is 50 upon QA to the power half into QA. This is nothing but 50 times QA to the power half. Okay, this is what I get for total revenue in market A. Okay, let me slightly correct it, guys. PA square is 100 by QA. This is 10. Please make this correction. This is 10. Because 100 square root of 100 is 10. So this is going to be 10. Please make this correction. So my TRA will be equal to 10 times QA to the power half. Now it's fine. So what will my marginal revenue in market A be? If I differentiate TRA with respect to QA, I get 10 times half QA to the power half minus 1. If I differentiate, this is going to be 5 upon QA to the power half. This is my marginal revenue in market A. On similar lines, I can quickly calculate the marginal revenue in market B. So I can write that from this equation, PB, this implies PB cubed is equal to 125 by QB, which implies my PB will be how much? 125 by QB whole to the power 1 by 3. This is going to be 5 upon QB to the power 1 by 3. So my total revenue in market B will be PB into QB, which is going to be 5 upon QB to the power 1 by 3 into QB, which is going to be 5 times QB to the power 1 minus 1 by 3, which is 2 by 3. So now what will my marginal revenue in market B be? If I differentiate total revenue in market B with respect to quantity in market B, I get 5 times 2 by 3 QB to the power 2 by 3 minus 1, which is 10 by 3 QB to the power minus 1 by 3, which I can write as 10 by 3 QB to the power 1 by 3. This is my marginal revenue in market B. Okay, so guys, this is my marginal revenue in market A. This is my marginal revenue in market B. So I can write in market A, at the profit maximizing level, of the monopolist, MRA should be equal to MC. In market B, at the profit maximizing level of the monopolist, MRB should be equal to MC. So guys, what do I learn from 1 and 2? In market A, at the profit maximizing level, MRA should be equal to MC. In market B, at the profit maximizing level, MRB should be equal to MC. We are given that both the markets have the same marginal cost. If you read the question carefully, we were given that both the markets have the same marginal cost. So from 1 and 2, what can I say? So if I erase this whole part off, okay, so I can write that from 1 and 2, MRA should be equal to MRB. What is MRA? 5 upon QA to the power half. What is MRB? 10 upon 3 QB to the power 1 by 3. Okay, so now we can quickly solve this. Okay, what is QA given to us? We are given that QA is equal to 100. So this implies 5 upon 100 to the power half is equal to 10 upon 3 QB to the power 1 by 3, which implies 100 to the power half is 10 is equal to 10 by 3 QB to the power 1 by 3. So now I can solve for QB, guys. So what does it come out as? If I erase this particular part off, I can write that therefore 5 if I cross multiply 15 times QB to the power 1 by 3 is 100. which implies QB to the power 1 by 3 is 100 by 15. Okay, so this implies how much is our QB? So I can further simplify. This is 5, 3s are 5, 20s are 20 by 3. So my QB will be 20 by 3 ka cube, which is 20 cube is 8,000 upon 3 cube is 27. So my QB is 8,000 upon 27. And now I can quickly calculate PB. Okay, so what was the expression for PB? Look at this. PB is nothing but 5 upon QB to the power 1 by 3. So PB is 5 upon how much is QB? QB is 8,000 by 27 to the power 1 by 3. So this is going to be 5 upon 8,000 by 27. So 8,000 to the power 1 by 3 is 20. And 27 to the power 1 by 3 is 3. So this is going to be 15 by 20, which is going to be 3 by 4, which is going to be 0.75. So the price charged in market B will be equal to 0.75. So on the top, I can now write the answers. Price charged in market B is 0.75. Quantity in market B is how much? Quantity in market B is 8,000 upon 27. And price charged in market A has come out as 1. These are the answers to these questions. These are the answers to these questions. So I hope all students attending this lecture have understood this for market A and market B. Okay, so I'm quickly revising. We were given the demand functions in both the markets. Okay, we were given that in market A, the monopolist is selling 100 units. So using that, I calculated the price in market A, which came out as 1. I found the marginal revenue in market A. I found the marginal revenue in market B. In market A, marginal revenue should be equal to marginal cost. In market B, also marginal revenue should be equal to marginal cost. But we were given in the question that both the markets have the same marginal cost. That means MRA should be equal to MRB. I equate, I put the value of QA as 100, which was given to me. I solved for QB. I got QB as 8,000 by 27. I put it in the expression for PB. I get the value of PB as 3 by 4, which is 0.75. These are all my answers for this question. Okay, so this is where I intend to stop in this particular lecture. The objective of this lecture was to discuss problems B and C from my assignment on monopoly and imperfect competition. Remember, Snyder and Nicolson back questions we have already solved in my lectures on worked out problems for Snyder and Nicolson. So students can refer to those videos where I've solved the worked out problems for Snyder and Nicolson monopoly. Okay, now in the next lecture, I will start with the discussion from question B onwards from my assignment. So I hope all students have enjoyed this lecture. Any doubt, you can unmute your mic and ask or call up, or you can mail me your doubts at divineschoolofeconomics@gmail.com. This is where I stop in this lecture.